Hello, dear friends. I, Hemant Sharma, welcome you all in our Vasu Electro tutorial class. So, in our previous class, we already discussed about inverting amplifier, and in that class, we discussed already about the inverting amplifier. What is inverting amplifier? And also in that class, we already discussed that and proved how the waveform we get at the output by designing circuit on the Tinkercad. So now in this class we discussed about the non-inverting amplifier. So what is non-inverting amplifier? As we know that a non-inverting amplifier is a type of operational amplifier. So in which the output signal is in phase with the input signal applied, or we may say that it is we get the amplified output signal, and a non-inverting amplifier behave as a voltage follower circuit. That is our non-inverting amplifier. And here you see this is the circuit diagram for the non-inverting amplifier. And from this circuit it is clear that as in our inverting amplifier we study that the second number pin of is for the for the inverting input, and third number pin is for the non-inverting input. So as if we want to use the operational amplifier as in inverting mode, so we use pin number second, and if we want to use the operational amplifier as in non-inverting mode, so we use third number pin. So as in the circuit diagram it is clear that the in order to operate the operational amplifier in the non-inverting mode, so we use third number pin. So here you see that this is the third number pin of the operational amplifier, and we give supply to the third number pin, and onto the second number pin we connect that pin to the ground. Okay, and here two resistances, R1 of 1 kilo ohm and rf is our feedback resistor, and R1 is our input resistor that is connected to the second number pin of the operational amplifier. So we connect these two resistances to the sixth number pin. So here we know that the sixth number pin is our output pin. So we connect these two resistances in this manner. So this is the circuit diagram for the non-inverting amplifier. So this thing more clear to you when I share a pin configuration to you. So here I want to share a pin configuration. So here this is the pin configuration of the operational amplifier. So a 741 IC is used, that is the IC of the operational amplifier, and this IC is have a total of 8 pins. So 8 pins, each pin have its own configuration. So the first number pin of the operational amplifier is for offset null. Second number pin is for the inverting input. As we know that the second number pin, if we want to use the operational amplifier in inverting mode, as we already did in our previous class, so we give supply to the second number pin, okay, and connect the third number pin to the ground. And if you want to use the third number pin for if you want to use the operation amplifier in non-inverting mode, so we connect supply to the third number pin and connect the second number pin to the ground. So the third number pin for the inverting non-inverting input, and also we give the fourth pin. The fourth number pin is for providing the negative power supply to the operational amplifier. So the fifth pin of this is offset null, and the sixth number pin of this operational amplifier for the output. If we want to get the output from the operational amplifier, so we use sixth number pin, and for providing the positive power supply we use 7 number pin, and the eighth number pin of this operational amplifier is not connected to anything. So generally in this pin we have mainly second, third and sixth number pin are very much important. Okay, so this is the pin configuration of IC, and in the IC this is the internally in the IC, this is the internal circuit diagram where the pins are internally shorted to each other like this. So this is the circuit diagram for the non-inverting amplifier. So now I going to design this circuit on the Tinkercad. So how to design that circuit on the Tinkercad? We will learn that how to design the circuit on the Tinkercad and how to get the input voltage in amplified form, as I already telling you at the start of this class. So now I open Tinkercad on my desktop. So here this is the window for the Tinkercad. So in order to perform that experiment, we have a requirement of breadboard. Okay, we have a requirement of operational amplifier IC, and also we have a requirement of uh, resistors, that is R1 and RF. Okay, so these type of resistors we have required to perform this experiment. So from the right side component library, we choose a breadboard. Here we know that what is the use of that breadboard. Breadboard is used for designing the circuit. Okay, so by rotating this we arrange. So now in the search bar I search for the amplifier. So by searching for the amplifier, we get the operational amplifier 741 IC. So rotate this and placing this IC onto this side. Okay. So this is our IC, that is 741 operational amplifier IC, and this is a 8-pin IC, as I already telling you. So the counting numbering of this IC is starting from the left side. So here this is our pin number first, second, third, fourth, fifth, sixth, seven, and 8. So this is a total number of 8 total number of 8 pins on that IC. Now search for the function generator. So as we know that the input to this IC is given by a function generator. So the operation of that function generator is to give the supply to this IC in square form, and to provide the pulses, to provide the input voltage in square form. Here you see square form, sinusoidal form, or triangular form. So we connect that, we give supply, and also do one thing, provide a wiring color also. So this is our, we arrange the color like this. So now we search for the resistors. So here this is my resistor that have value 1 kilo ohm, and we place that this is our resistance R1. So by the circuit diagram, we know that the second number pin of this operational amplifier is ground. So when I share the screen and show the circuit diagram to you, here you see that the resistance R1 is connected to the ground, and the first end of this resistor is connected to the ground, and the second end of this resistor is connected to the second number pin. So similarly, we place this resistor onto this side. So now take another resistor and having value of 10 kilo ohm, and we place the name of that resistor is RF. So RF is our feedback resistor, and that resistor is connected to the sixth number pin. So here you see this is my sixth number pin, and when we connect the second terminal, one terminal of this resistor to the sixth number pin, and second terminal to the resistance R1. So we take a wire from the second number pin and connect that to the Just a minute. So we connect the resistance R1 to the feedback resistor and give the color of this wire to pink like this. Okay, so in this way our resistance R1 and RF both are connected to each other, and the resistance R1 connected to the ground, and the resistance RF is connected to the sixth number pin. So the next thing what we want to do, the next thing is we give the supply to the third number pin. Okay, and now this is our pin number third, and we give supply to the third number pin like this. Okay, so give the color of this wire to red, right? So now we want, what we want to do, we know that the fourth number pin is fourth number, we give the supply to the fourth number pin, negative power supply is given to the fourth number pin, and seventh positive supply is given to the seventh number pin. So we search in the search bar for the power supply. So here you see this is our power supply. Put that power supply onto this side, and in order to give the negative power supply to the fourth number pin, we reverse the connection. Okay, so how to reverse the connection? So we give the positive, we give the negative end of this power supply to the fourth number pin, and positive end of this power supply to the ground. Here has, this is my ground. Okay, so we, by doing this, we give the negative power supply to the fourth number pin. So similarly, if we want to, we use 7 number pin, 7 number pin for the positive power supply. So here you see that this is our fifth number pin, this is 6, and this is 7. So we connect our positive end of this power supply to the 7 number pin like this, and give the wiring color to red. And similarly, negative power supply is connected to the negative layer of horizontally shorted slots, and give the color to black. So in this manner, the whole circuit arrangement is designed on the breadboard. So do one more thing. Here we take a wire from the negative layer of the horizontally shorted slots, and connect that wire to the another layer of horizontally shorted slots, and give the color to black like this. Okay, so now the complete circuit arrangement is done. So on the search bar we search for the scope, because oscilloscope is used for the measurement of input power supply and also for the output. So in order to measure the input and output, we use a scope. So we connect the positive end to the positive end, and negative of that scope to the negative end. Here you see like this, and give the color to black. And similarly take the another, and as we know that in order to take output, so we use 6 number port, 6 number pin. So here you see this is my 6 number pin, and we connect that to the 6th number pin, and negative is connected to the negative layer of horizontally shorted slots, and give the color to black. right? So now if you want to, in order, as our circuit is complete, and in order to set the parameters, so you may set the amplitude of the function generator. You may set from point 10, and the DC offset voltage to point 50, and function, the function is used that which type of voltage we want to give to the 741 IC. So these are square, sine and triangle. So we want to give sine wave to the third number pin of 741 IC. So by doing this, so our whole connection is complete. And one more thing, by clicking on the oscilloscope, we have to set the time per division axis. So we set to 1 millisecond. Okay, so by doing this, our circuit diagram is complete. So as our circuit is complete, so when I start simulation, we will see that this is our input supply, and this is our output supply. So as you see here, when I zoom the screen, and we will find that the this is our input supply, that is 2 volt. Okay, and this is our output voltage, that is amplified, and that is also in phase with the input voltage, and that is amplified to the input signal. And the output voltage we get 20 volt at the output. So this is the circuit designing of non-inverting amplifier. So one more thing, we have to, by clicking on this, and we have to give 12 minus 12 volt supply to the fourth number pin, and plus 12 volt supply to the 7 number pin of the operational amplifier. And you also see that the output current is greater than input current, that is 3.14 milliampere, and that is 2.64 milliampere, that is our currents. Okay, so this is all about the non-inverting amplifier. And if you want to save that onto this screen, so you may save in the name of non-inverting amplifier, and click on the screen. So this experiment save in the name of non-inverting amplifier. So thank you very much. I think you grab a lot of things in this class. So please do like, share and subscribe my channel. So thank you very much. Have a nice day to all.